All right, welcome to IM2 2.1 notes, multiplying polynomials. Objective today, students will be able to multiply polynomials with monomials and binomials. Let's just talk quickly what I mean about that. A monomial, anytime you see that word mono, that's a prefix that means one. So like this is one term, and so therefore that's a monomial. That's a monomial, monomial. And if you scroll down here, you can see we'll get some things that have multiple terms. So down here, example 3, it has 3 terms. So we'd call that a trinomial, right? Because it has 3 terms. And then if you go down even further, we have 2 terms. See, x plus 2, that's 2 terms inside the parentheses. So we'd call that a binomial. So this is like a binomial times a binomial, and so on. So some basic words. Now, polynomial is just kind of like an umbrella term for all of them. It just means multiple nomials. So it's just an umbrella term for all of them. All right, so let's talk about how we do this. We're just multiplying. And so let's make sure we clearly understand here. When you multiply a monomial times a monomial, all you do is you just multiply the coefficients. And by coefficients, I mean these things highlighted up front. So you multiply the coefficients, so -3 times -9 makes positive 27. And then you add the exponents, okay? As long as the bases are the same. And in this situation, they're both a base of t. So t squared times t cubed, that would make t to the 5th. Now, why do we add them real quick? Well, let's just think about that real quick. Let's say I was to have like x squared times x cubed. So I'm going to add them, and it's going to make x to the 5th. But why is that? Well, what does x squared really mean? Doesn't x squared mean x times x? And doesn't x cubed mean x times x times x? Well, if I multiply all those together, how many x's do I have total? I have 1, 2, 3, 4, 5 being multiplied together. So that's why we just added the exponents together, and boom, we have x to the 5th. So that's why that is the way it is. Okay, so now you see how to do that. I want you to go ahead and just try practice number 1 on your own. Give it a shot, and then unpause the video when you're ready to check your work. Okay, so hopefully you saw -5 times 3 is -15. And then b to the 6th and b to the 3rd makes b to the 9th. And that's it. Okay, let's go to the next problem here. Okay, now it says find the values of a and b that satisfy the following equation. All right, so let's think about this. What we're really saying here is what value times -4 would equal 20? Well, what times -4 equals -20? That's easy. It's -5. So a would have to be -5, right? -5 times -4 makes positive 20. And then what we're saying next is x squared times x to what would make x to the 6th. Well, since we know that we have to add here 2 plus what would make 6, it'd have to be 4. And so we could say that b has to be 4. Box our answers. We're ready to go. So I want you to go ahead and try that on practice 2. Try that on your own. And again, check back with me when you're ready to check your work. All right, so hopefully you saw that a times -2 has to equal -12. Well, the only thing times -2 that makes up -12 is positive 6. And then 3 plus what makes 8? It would have to be 5. All right, let's keep going with this. Evaluate the product of the monomial and the polynomial as a trinomial. Okay, so what we're saying here is they want us to multiply this, and they want us to distribute it to everything. That's all we're doing. And since it's just a monomial times a trinomial, nothing real fancy we have to do here. The main thing, we just have to remember that we have to multiply this to every term. That's it. So let's just do it. 6 times 7 is 42. Z squared times z squared makes z to the 4th. All right, now we're going to do 6z squared times 2z. Well, 6 times 2 is 12. And z squared times z, you could think of this as z to the 1. When there's no exponent there, you think of it as a 1. So z squared times z to the 1, that would become z to the 3rd. And then lastly, we have 6z squared times -3. So 6 times -3 is -18. And then there is no z, so it's just like, essentially it's like having a z to the 0, right? So 0 plus 2 is still 2. And there is our answer. Boom. All right. So all you're doing is distributing to every term. So go ahead and try practice 3 on your own. And again, unpause the video when you're ready to check your work. Okay, I threw you a curveball here. I don't know if you saw it or not. But notice we're multiplying a y times a z. What do we do that when we have 2 different variables? You just put them together. That's it. Here's how you multiply y times z. We tend to like to put them in alphabetical order. That's like how we would do it in standard form. So that's all we do there. And we don't know what y is, we don't know what z is, but hey, we got a little placeholders for it. Everything's nice and organized. So we're good. All right, let's take a look at example 4. Find the values in a, b, and c that satisfy the following equation. Okay, so this one I want to show you a way that we could kind of do this to set this up, and it kind of segues into the next thing, is I want to teach you something we can use called the box method. Anytime you're multiplying, you can use a box method. So I want to just show you what that could look like here. So I'm going to put the -4 out on the side, and I'm going to make a long box. And I'll put 2x squared plus a to the x plus b here. And then I'm going to go ahead and put my answer. See, I already know what my answer is. I just have some pieces missing. I'm going to put my answer right here. Cx squared, 12x, and -16. Okay, so now we have these little mini, I guess, equations that you could think of, right? So I'm going to do -4 times 2 equals what? Or I could say -4 times what to get 12? And lastly, I could say -4 times what to equal -16. And hopefully you could figure this out now. Hopefully you should see that, well, if I did -4 times 2, c would have to be -8. If I did -4 times what to equal 12, the only way to get a positive 12 would be if my a equaled -3, right? Because a -4 times a -3 makes positive 12. And then for the green one, -4 times what makes -16? Well, my b would have to be positive 4 because -4 times positive 4 makes -16. So I think if you see that kind of lined up, and the reason why we can know that is simple. It's just this. Aren't these both x squareds? Aren't these both x's? And aren't these technically like x to the 0? And so we don't have to stress too much about what's going to go where. We know which pieces are going to go with what. All we're trying to find is the coefficients here. So I want you to try to do the same thing here with practice 4. Give it a shot. And again, unpause the video when you're ready to check your work. All right, hopefully you worked this out. First I want to point out is this time we're multiplying with a y to the 1. And so that's why all of our answers are going to have one more degree or one more in the exponent. So y to the 1 times y squared, that's going to give us y cubed. So that's how we know the y cubed goes here. Y to the 1 times y to the 1, that's going to give us y squared. So that's how we know the y squared goes here. And finally, y to the 1 times y to the 0 is going to give us y to the 1. So that's how we know where each thing goes in my box. And then all I have to do is 3 times what equals 24? Well, that's 8. 3 times -7 equals -21. And 3 times what equals -12? Well, that's -4. And so I have all my answers. Okay, let's keep moving on here. Okay, it says find the trinomial expression that is equal to the product below. And we're going to use the box method. So you might have heard of other ways to do these types of problems. Maybe you heard of FOIL. And FOIL works good when it's a binomial versus a binomial, but it's going to get more complicated. And so we need a more organized method. And this is why I recommend the box method. And so here's what I say to do with the box method. I say you put one of them on top. It doesn't matter which one goes on top. And one on the side. So see how I put x minus 1 over here on the side. And you just multiply each thing. So x times x, that's x squared. X times 2, that's 2x. -1 times x, that's -1x, or we could just write -x. And -1 times 2, that's -2. Okay, now the only thing you have to know is once you fill out the box, you have to add everything on the inside. Well, there's nothing that goes with x squared. There's nothing that combines with x squared. There's no like terms, right? These have x's in it, but they don't have a matching degree, and therefore they can't fit. We can't add it to that. So I would say that this equals x squared plus, now these do match. See, they're both technically an x to the 1. And so we add those together. So +2 and -1x makes +1x. So I would just say plus x. And then lastly, the -2 is all by itself, so -2. And so here's my answer written in standard form. By the way, standard form is just when the degrees go from highest to lowest. So I have a degree of 2, I have a degree of 1, and then technically I have a degree of 0. And so it's all in the correct order. All right, so I want you to try it on practice 5 here. make a box, work it out, see if you can get the answer. Just a little trick that you might want to be aware of, though. I usually like to put the negative up on top if there is one. If they're both negative, put the negative in front of the number here. Like if it was x minus 3 and x minus 4, I'd put a minus 4 here. The reason being is sometimes people put, like, if I was to put x, I'll just show you. If I was to put x minus 3 on the side and you put it like that, you'll forget about that. You'll think maybe it's division or something, and so that doesn't look right. So don't do that, okay? All right, so here's what you should have gotten inside your box: x squared, negative 3x, and 4x. And then you should have noticed that these are like terms. And so you end up with x squared, 4x minus 3x makes 1x. So I'm just going to say plus x and then minus 12. And boom, you have your trinomial. That is the product of these two binomials above. All right, let's go to the next page. All right, so we just have another binomial times a binomial. We're going to use the box method again. Sometimes what you can do when you're doing these types of problems is you can kind of just draw your box right below one of the already existing things there. Save yourself some space. Again, I'm going to put the minus sign in front of the 5, not like above it, so don't get confused. And let's work this thing out. Okay, so 7k and 3k. Well, 7 times 3 is 21, and k times k is k squared. 3k times negative 2, that makes negative 6k. Negative 5 times 7 is negative 35k. And then finally, negative 5 times negative 2, that makes positive 10. All right, the only ones that have like terms are these ones with just a k. So when I go to write my answer, I have 21k squared minus 35 and 6 makes negative 41. So we're going to write 41k and then plus 10. And there we have our answer. So just multiply on the outside and add up on the inside. And again, remember, you can only add these together. If you're not sure as to why you can't add that, ask me in class. I'll explain why that is. All right, here's practice 6. I want you to give it a try. Again, draw out your box method to keep it organized. It's going to get a little nasty now because you got some exponents. Don't fret. It'll be easy. Go ahead and work that out. All right, so like I said, it was a little bit different this time. Here's what you should have got inside your box. I did this one on top. I could have done this one on top. It doesn't matter. But notice we don't get any of the same exponents. Right? And here we get a constant all by itself. But here all of our exponents are different. And so when we go to add them together, we just literally write it as adding together. That's it. That's all we can do. We can't make it any simpler than that. All right, let's take a look at example 7. And now this is the real reason why we use the box method here. Okay, it's because when you start to get some nasty problems like this, you really need a way to keep it organized. FOIL will not work on a problem like this. It just doesn't work. It only works with binomials and binomials. So if you don't know what I'm talking about with FOIL, don't worry about it. It's just for those people that have maybe learned that in the past. So let's make a bigger box. That's all we got to do. That's why we learned the box method. We got a bigger problem. All we got to do is make a bigger box, and that's it. So 3x and 4 over here. Put in my lines. And let's work this baby out. So 3 times 2 is 6. X times x squared is x cubed. Again, remember we add the exponents. 3 times 7 is 21. X times x is x squared. 3 times negative 5 is negative 15. And there is no x, so it just stays as 1x. Do the bottom row here. 4 times 2, that's 8x squared. 4 times 7 is 28x. And 4 times negative 5 is negative 20. Okay. Hopefully you see what I see. There are multiple things that are like terms now, right? So see these? These both have just a singular x, and these both have an x squared. So we're going to add those together when we go to write our final answer. So I'm going to start with the highest degree, which is 6x cubed. 21x squared, x squared, and 8x squared is 29x squared. And 28 minus 15, that is 13x, and then negative 20. All right, there we go. I want you guys to try this last practice problem on your own. Give it a shot, make that big box like we just did, and work it all out. Again, remember to check back when you're done with your work. Okay, hopefully this is what you got. Here's what I got inside my box. Again, I had these like terms and these like terms, so I add them together here, right? So this became 5b cubed, and this became 12b squared. And that's all I could add together. So there's my final answer. Boom. Now, for the summary. It says, suppose you had a rectangle with a width of 2x minus 5 and a length of 4x squared minus 3x plus 2. Now, we don't know what the x is here. It doesn't matter, though. We're just saying, hypothetically, you got a width with 2x minus 5 and a length of 4x squared minus 3x plus 2. By the way, a rectangle isn't another name for a rectangle, just a box. Big hint there. Since the area of a rectangle will be found by multiplying the length to the width, find a polynomial expression that represents the area of the rectangle. Hint, draw a sketch and use the box method. Yeah, there you go. Give it your best shot, and I'll see you guys in class.